In this video, we're going to look at the insertion sort algorithm. Here we have a list of 8 integers which are unsorted. The insertion sort algorithm works on the basis that one section of the array or list is sorted and the other section is unsorted. Here, by definition at the start, the 0th element by itself is sorted. We can see the red dashed boundary will indicate for us the sorted section and the unsorted section. Our intention is to look at each element in turn in the unsorted area and position it correctly into the sorted area. So the first thing that we need to do is to create a for loop that goes from position 1 to the end of the list. We'll do that in Python now. So in Python, I will start by declaring a list of integers. Then I will call upon a method called Insertion, and now I'm actually going to create the method here with one parameter, which is the list. The first thing that we were going to do is have a for loop that goes from position 1 to the end of the array. So how does the insertion sort work? What happens is we take a copy of the current position of the for loop, looping variable, which is 1, and we will look at the value which is 1 lower than that. The other thing that we do is we take a copy of the value which is held in the position that we're currently trying to place, and here I'm going to write that into temp. In Python, we will say that position is equal to I and that the temporary variable is equal to num's position. Now we simply compare the temporary variable to the variable which is located here. Is 2 less than the value held at position 0? The answer is yes. So in that case, what we do is we copy the value at position 0 and shuffle it to the right. Now, because we have come to the end of the list or array, we can copy the 2 into the sorted position here in 0, and then we have finished the inner loop and we'll be on the next section of the for loop. We'll run through that again a couple of times. So here we have the number 6. First thing we do is we copy the position value 2 and also copy 6 into the temporary variable here. Then we compare 6 with the value that is held at position -1, which is 4. Is 6 less than 4? No, it's not. So therefore, this is sorted already, it's in the correct place, and we can move to the next loop of the outer for loop. Once again, first thing that we do is we take a copy of the looping variable, which is 3, and we put the position pointer there. We take a copy of the value that is held at position 3 in the list and write it to temp. Now we compare this value, temp, with the value at position -1. Is 1 less than 6? Yes, it is. So we shuffle the 6 to the right. Then we decrement position pointer. Is 1 less than 4, which is at position -1? The answer is yes. So we shuffle the number 4 across and we decrement the pointer. We say to ourselves, is 1 less than the value at position -1, which is a 2? The answer is yes. So once again, we shuffle this across. We decrement the pointer. The other condition where we stop this loop is where the pointer, which I've called position, is less than 1. So here, position is pointing at 0, which is less than 1. Therefore, the inner loop stops. we need to add a line of code underneath the inner loop, which will then copy the temporary value to wherever position is pointing. So the inner loop is a while loop which has two conditions. While the position pointer is greater than 0 and the temporary value that we have held is less than that which is held at num's position minus 1. And if this is the case, what we do is we shuffle the position at minus 1 into num's position, and we decrement the pointer, which I have called position. When we have completed these comparisons, then we have to write the temporary value into num's position. I'm now going to print the array or list to ensure that this works. And we can see that we have got a sorted array here. In this video we have covered the insertion sort. We can now see on the screen the insertion sort and the bubble sort algorithms for your reference. Thanks for watching, and I'll see you there.